Hey guys! Welcome back to the laboratory. In this video, we are looking at bond energies. By the end of this video, you should be able to define the term bond energy, calculate energy changes in reactions using bond energies, and use bond energies to determine whether a reaction is exothermic or endothermic. So, let's go! During a chemical reaction, energy is exchanged with the surroundings as bonds in the reactants are broken and new bonds are made in the products. The bond energy is the amount of energy needed to break 1 mole of a particular bond. For example, the hydrogen to hydrogen bond has a bond energy of 436 kilojoules per mole. This means that to make or break 1 mole of hydrogen to hydrogen bonds, 436 kilojoules of energy is absorbed from or released to the surroundings. Breaking bonds is an endothermic process as it absorbs energy from the surroundings. So, to break 1 mole of hydrogen to hydrogen bonds, 436 kilojoules of energy is absorbed from the surroundings. However, bond making is an exothermic process as it releases energy into the surroundings. So, to make 1 mole of hydrogen to hydrogen bonds, 436 kilojoules of energy is released into the surroundings. We can use bond energies to calculate the energy changes in a chemical reaction and determine whether the reaction is exothermic or endothermic. To calculate the energy changes in a reaction, we must calculate how much energy is taken in, how much energy is given out, and find the difference between the two values. Let's look at the reaction between methane and oxygen, which produces carbon dioxide and water, as an example. Before you begin any calculation, it's important to ensure that your equation is correctly balanced. The balanced equation for this reaction tells us we have 1 molecule of methane, 2 molecules of oxygen, 1 molecule of carbon dioxide, and 2 molecules of water. The bond energies for the different bonds in this reaction are provided here, and these will be provided in your exam papers too. To start, we must calculate the energy absorbed from the surroundings to break the bonds in the reactants. This is the energy in. In our reactants, we have 4 carbon to hydrogen bonds in our molecule of methane, and 2 oxygen to oxygen bonds in our molecules of oxygen. So, our energy in is equal to 413 times 4 plus 498 times 2, which is equal to 2,648 kilojoules per mole. Next, we calculate the energy released into the surroundings to form the new bonds in our products. This is the energy out. In our products, we have 2 carbon to oxygen bonds in our molecule of carbon dioxide and 4 oxygen to hydrogen bonds in our molecules of water. So our energy out is equal to 805 times 2 plus 464 times 4, which is equal to 3,466 kilojoules per mole. Our final step is to subtract the energy given out by the reaction from the energy taken in. 2,648 minus 3,466 is equal to minus 818 kilojoules per mole. The energy change in this reaction is negative, meaning that the reaction has lost energy to the surroundings. This is therefore an exothermic reaction. Had the value at the end of this calculation been positive, that would have meant the reaction was endothermic, as it had gained energy. Here's an example for you to try on your own. Pause the video and take your time to work through the question. Press play once you're ready to check your answer. Hydrogen and oxygen react to form water. The balanced equation for this reaction has been provided below. Calculate the energy changes in this reaction and determine whether this is an example of an endothermic or exothermic reaction. Just as we've done in the previous example, we are going to calculate the energy changes in this reaction by determining the energy that was taken in, the energy that was given out, and calculating the difference between the two. The balanced equation for this reaction tells us we have 2 molecules of hydrogen, 1 molecule of oxygen, and 2 molecules of water in this reaction. To start, we calculate the energy absorbed from the surroundings to break the bonds in the reactants. the energy in. In our reactants, we have 2 hydrogen to hydrogen bonds and 1 oxygen to oxygen bond. So our energy in is equal to 436 times 2 plus 498, which is equal to 1,370 kilojoules per mole. Next, we calculate the energy released into the surroundings to form the new bonds in the products, the energy out. In our products, we have 4 oxygen to hydrogen bonds, so our energy out is equal to 464 times 4, which is equal to 1,856 kilojoules per mole. Finally, we subtract the energy out from the energy in. 1,370 minus 1,856 is equal to minus 486 kilojoules per mole. The energy change in this reaction is negative and is therefore an exothermic reaction. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!